Okay, hello everybody. Sorry, the only French I know is like bonjour. So yeah, I'm really sorry about that. Is everyone comfortable with English? Yeah. Good. And just before I start, I want to apologize for Brexit. It's not my fault. I didn't vote for it, but apparently 50-something% did. So okay, today I'm talking about Grafana Loki. This is a new project we released in December. It's, yeah, like Prometheus, but for logs. So, a little blurb about me. They call me the VP product, but I'm really a programmer. I'm really a software engineer. I'm one of the Prometheus maintainers. I work on another CNCF project called Cortex, which is a horizontally scalable, highly available version of Prometheus. I started that project. And now I started the Loki project as well. I'm on Twitter. I normally use this as an opportunity to beg for followers. I'm in a bit of a competition with my wife, but she's a journalist, so she's going to massively overtake me. So first, a bit of audience participation to warm everyone up. Who's heard of Prometheus? Who uses Prometheus? Keep your hands up. Wow, that's great. Who uses something other than Prometheus? And be aware, I'm going to ask you what you use.
A bit of telegraph on Influ.
Well, and why do you use Influx and Telegraph over Prometheus?
Because I'm using telegraph on Influ for our Vim stack.
Okay.
Prometheus is way better for Kubernetes, basically.
Okay. You can use Prometheus for non-Kubernetes workloads.
Yeah, that's like
it's going to be half an hour of this, by the way.
Prometheus can have.
Yeah, no, don't worry. Cool, thank you. So, we'll get started with Loki. So, Loki is a log aggregation system, and most people here, I guess, are familiar with Elastic. Familiar with Elastic? Yeah, good. I'm not, actually. I've used it a couple of times. All I know is it's a horror show. Is anyone here from Elastic or working on Elastic? Because I accidentally slagged off Elastic and like one of the authors was in the audience. Is this being recorded? Good. So yeah, I started the project in March, actually, like quite a long time ago. It was, I had a company before Grafana Labs called Kausal, which did a hosted Prometheus and logging system, and I actually started the project there. But we got bought by Grafana Labs, and that's really where we kind of continued it and open sourced it and really worked on it. We launched it at KubeCon in Seattle. That was a bit crazy. We were like #1 on Hacker News all day. We've now over 5,000 GitHub stars. We had people coming up and taking selfies with me. It's crazy. It's all open source, of course, and one of the things I'm very keen on, you'll see it in Cortex and all the other projects I work on, is I like to do design documents, and I like to make them public. So there's quite a long, like 10-page design document about why we've done Loki the way we have. And really, this talk is going to be a run-through of some of that. So the talk's going to be 3 things: why we've done Loki and what we've tried to achieve. So we want to make it simple and cost-effective to operate. So this basically means we want to make it easier to operate than Elastic, right? And we want to make it cheaper to run as well. I mean, I've heard some horror stories about Elastic, and I've seen how much vendors charge for hosted log aggregation, and we want to charge a lot less. You know, we are doing this with some commercial things in mind, like we're going to offer a hosted version of Loki, but everything we do at Grafana Labs is open source, and the hosted version of Loki is running the same code base. All our config for how we run it, all the monitoring we've built for how we run Loki, that's all in the repo. So if you want to compete with us, good luck. So the second reason I did this is, and I'll go into a lot more detail, is I wanted to have a more like joined up story for observability. Right? I wanted to have my monitoring system and my logging systems talking to each other. And in that kind of heat of the moment when I'm getting paged at like 4 o'clock in the morning, which happened this morning, and yesterday, and the day before, like I want to make it easier for me to find the things I need. So I want to join up the story. And then finally, like I'm a massive cloud native zealot. I've been I spent a few years at Google doing things in the microservices, you know, Borg style before Kubernetes existed, and I just wanted to build a really truly cloud native log aggregation system. And if you're reading between the lines, that means no Java. So first, simple to scale. How did we make it simple to scale? So this is not very precise, and if you want to pick me up on the details, then have at it. But for now, like you can imagine, you get a log event coming into your system, and it's assigned some identifier. And the log event's probably a JSON blob. You know, it's got some fields. And then most log aggregation systems are going to fully index all the fields in that log event. right? So they're going to go and look in the log line, and they're going to break it up into lots of different entries. And they're going to build what's called an inverted index. So this is where you effectively take one entry and like invert it and turn it into, here are the example I've turned it into 7 entries. And this is what Elastic does. This is what most of the kind of search systems do. This is also how Google searches the internet. This is a very common technique if you look up inverted indexes. But also, I think it's pretty widely accepted that inverted indexes are hard to scale. When you ingest this thing, these keys in your inverted index are going to get sprayed over all your nodes. Right? And this makes it hard to make this fast. You add more nodes, it's still getting sprayed over all the nodes. OK, they're getting less traffic each. And similarly, queries have to go and touch lots of nodes. What's more, I think you'll find, with a lot of the inverted index systems, the index itself tends to be the same size as the data you're indexing, which is pretty big. We want our log aggregation systems to be indexing petabytes of data. And if your index is petabytes of data and indexes are hard to scale, then you're going to have a bad time. And then the final point about this is, if you look at this index, if you look at this inverted index, you can see that the cardinality of the values inside here, so like the number of different values you can have inside here is unbounded. It's very, very large, which also constrains how you design your index and the technologies and techniques you use to do that. So for people who are familiar with Prometheus, you'll recognize, like I'm building up to, how we do this. We don't index the contents of the logs with Loki. Well, it's not as powerful as Elasticsearch, and that's not our aim. We index a small set of limited labels that point to a stream, a log stream. So that's a time-indexed collection of bytes, effectively. And so because we index so much less data, our index is tiny. In our production environment, our index is less than 1% the size of the data we're indexing. And the cardinality is much smaller, and it's much easier to scale. In fact, it will just fit on one machine. You don't really have to scale the index. And then, of course, the data that you're pointing to, the streams, can be absolutely massive. We've already got petabytes of data in our hosted version of Loki. We've only been running it for a month or so. So yeah, so the big difference Loki makes over things like Elastic and Splunk is that we don't bother indexing the text of the stream. Is that we just index some metadata about the stream. And then when you want to come to query time and you want to query that data, all you can do is give us some selectors like Prometheus saying, give me all the streams that kind of match this set of selectors. And then you can give me a regex that will go and run over all those streams in a kind of distributed grep. And that's all you can do. So it's super simple. It's designed really for kind of pod logging, the output of your applications. It's not really designed if you're building big analytics systems off of Elasticsearch. This isn't going to really help. If you're doing anything with numbers, it's my opinion you should be using metrics. You should be using Prometheus. So this is really built as a complement to Prometheus. So one of the other nice things about this is because all of the streams are grouped together, all of the data from a single stream is grouped together, we build up these nice compressed chunks. And anyone here familiar with columnar compression will recognize that data coming from a single place tends to have much lower entropy than all your data. So it compresses much better. And this is how, in the Prometheus world, we get such good compression on time series data. And so we don't do anything nearly as clever as Gorilla encoding. We just use gzip. But it's still getting over 10x compression on our data. And we don't have a big index, so it works really nicely. And so that's how we've kind of made it easy to scale by kind of just ignoring the hard problems or working around the hard problems. And we've made it cheap to run by getting much better, much more proactive with the compression. So this is, by the way, the first time I've given this talk. I'm giving it at FOSDEM in Brussels in 2 days' time. So any feedback, anything that's not clear, please ask me questions, and I'll iterate on this. This is probably going to be the talk I'm giving for most of the year. So integrating with existing tools. I've talked about how I get paged a lot. Actually, at Grafana Labs, we're only about 30 engineers, and all the VPs, all the management, all the L team, we're still on call. And so I've been on call now, probably 6-7 years. And one of the things that really annoys me, internally within Google, the tools are really good. You've probably heard other people say this. And they're all really joined up, and it works really well. And then you get to the outside world, and you've got to kind of build your own, assemble your own observability experience. And it kind of sucks. You end up with this world where you get a page in the middle of the night, and maybe if you're really good and if you've prearranged it, your page might link to a dashboard, Otherwise, you've got to go and find your own dashboard. And then, your dashboard's good, because you've probably curated them if you're doing it correctly. You've stored them in Git and you're iterating on them in PRs and so on. But it's not going to be perfect because every page is different. And so you're going to want to take the query out of one of these panels and you're going to want to fiddle with it. And you're going to want to try and, narrow down and really dig into that query to get to the data you want. Funnily enough, this is the slide from our pitch deck for my first startup, for the Kausal startup. And then once you've kind of identified, maybe you've identified the service, the host, the job, whatever that's causing the errors or got the high latency, you're then going to go and want to look in your log aggregation system. That's Logly, which we were using previously. And you'd have to, between these two steps, you've got to translate your query. The labels and the metadata and the query that you use in Logly is different to the one you use in Prometheus. And then, maybe, distributed tracing because it's trendy as well. You've got to translate your query in there as well, and then eventually you figure out what it is and you fix it. And this is a pain. And so it's been my, my dream for 2 or 3 years now to make this a lot simpler. So let's dig into that a bit more. You all said you're pretty familiar with Prometheus. That's more than 50% of you, so I'm going to go through this really quickly. Prometheus is a very simple data model. You've got these time-indexed series of values, of numbers, called time series. The timestamps are milliseconds, the values are floats, that's it. And then you've got these identifiers. And these identifiers are bags, you can think of them as maps, if you like, of label value pairs. And that's it. That's the whole Prometheus data model on one slide. Everything you do involves matching against label pairs and aggregating against time-indexed numbers. And so where do these label pairs come from? This is kind of the whole key, the thing that makes Prometheus really powerful is it integrates with your service discovery systems. So, we're at CNCF meetup here, so I'm going to talk about Kubernetes. But it's not just Kubernetes. You can use DNS, you can use Console, you can use anything. But Prometheus will talk to your service discovery system. We'll get back a big list of things. You get to configure what it is. So in Kubernetes, it could be a list of pods. It could be a list of nodes. It could be a list of services. You get to say what you want. But these just come back as big sets of dictionaries. And then you get to do this thing called relabeling. And if any of you have who's done relabeling here? Who's played with their relabeling config? Yeah, it's horrible, isn't it? Yeah, sorry about that. Well, I didn't write it, but that's like lifted straight from how Google did it. But you get to do these relabelings, which is executing a set of rules on these dictionaries that get to kind of munge things. And so a good example would be the rules that I use internally for all of my monitoring and have done for a few years now. I like to include the namespace in the job label. So instead of, because I quite often have like a dev and a test namespace, a dev and a prod namespace in the same cluster. And of course, they've got jobs called the same names in both dev and prod. And I find quite often I was accidentally aggregating together like the performance of my prod jobs with the performance of my dev jobs. And that really annoyed me. So I started to include the namespace in the job name. This is an opinion, right? I wouldn't tell all of you to do that. I know not many people do that, and I'm a bit out there. But relabeling allows me to express my opinions in code, right? And they allow me to encode mistakes I've made and solutions to mistakes I've made in the past. So I've, over the past couple of years, developed this set of relabeling rules that I really like, and it gives me my metadata in the format I like. Prometheus will then use all of those relabeled targets to reach out to your applications, scrape the data. They'll then combine the labels from your relabeling rules with the labels from the series to the final label set. So that's how Prometheus works, in a nutshell. So Loki's incredibly similar. I actually just copy and pasted the slide. I changed the logo. We had to make timestamps a bit more accurate, purely because, in Prometheus, your metrics come in very regularly, maybe every 15 seconds or every 30 seconds. But your log lines, they're going to come in very irregularly. And so you need the nanosecond just to dedupe 2 log lines that came in very similar to each other, very, very close to each other. Obviously, the values are now byte arrays, because this is logs. But the identifiers are the same. They're just label sets. They're literally the same types in Go. And then if you look at how Loki's architecture, very basically, drawn with Keynote, Promtail embeds the same service discovery library that Prometheus uses. I mean, we just vendor Prometheus into Loki. It will reach out to Kubernetes. It will gather your set of labels. You can do the same relabeling. Literally, I have the same config copied into my Promtail config so that my labels are consistent between Prometheus and Loki. It will then, instead of reaching out and scraping jobs, it actually reaches out and tails files. So you run Promtail as a daemon set on every node, You give it a glob matcher that matches files in the file system, and it will go and follow them, slurp in the data from them, add the labels it's discovered, and send them to Loki. All these slides, I'll tweet these slides later, so don't need to take photos or anything. And then you get to this. So this is, unfortunately, I was doing these slides on the Eurostar on the way over, literally over in the past hour, and the Wi-Fi was terrible, so I couldn't get the high-res version of this. So I do apologize, but you can just about see that the job label here, Tempo Dev, the project used to be called Tempo. Tempo Dev Promtail, job Tempo Dev Promtail. The labels are the same. And this is new in Grafana 6. You can have what we call the Explore mode with side-by-side, like interactive Prometheus and Loki. And you can, obviously, yeah, it's awfully configurable as everything is. So you can have your metrics side-by-side with your logs now in Grafana. And as you can probably tell, you know, this was the same picture I showed you at the beginning, but now Grafana has kind of taken over these 3 squares, all within one UI. And it's all just a click away. You never have to rewrite your query. And in an instant response scenario, if you've just been paged in the middle of the night, this makes a big difference. I can still be asleep and basically execute this, whereas previously I'd kind of have to wake up. This should also, for those who are paying attention and really watching, this should kind of give you some idea of where I want to go this year. Like, I've already got a prototype of these 2 things. You know, Grafana 7, that'll be fun. So, we've done ease of scaling and cost. We've done integrations with Prometheus. And last one, I've put in cloud native because it's cloud native meetup. And this is kind of my grab bag of all the other things that Loki is, all the trendy things. So it's containerized. You know, we build Docker images. Everyone does nowadays. We also, you know, when I say Kubernetes native, what I mean is, you know, this is built to run on Kubernetes. You know, all the pod life cycles have been worked out. All of the configs are shipped. You know, we've got Helm charts. We've got Ksonnet is my tool of choice, which is a config management system for Kubernetes that uses a language called JSONet, which is awesome. Dave, I can't remember his second name, the author of JSONet is now in London. And it's very similar to the internal tool that Google uses, which is called BCL. Very similar to BCL and how Google manages its jobs on Borg. So, you know, we're very Kubernetes native. We have this, and actually this is what I'm going to go into a bit more detail. We have this optional microservices mode. This is when I touched on at the very beginning that we run this internally, well, externally, as a product that we sell as a service. And we run it as a set of microservices, not as a single binary. So I'll go into that in a bit more detail. And then finally, it's all built to use cloud storage. You know, once you've ingested these logs, you've built these chunks, it's going to flush them to S3 or GCS. It's going to put this index, this small index, in Bigtable or DynamoDB or Cassandra. And so it's built to use NoSQL, you know, cloud storage. You know, horizontally scalable. There's no SQL anywhere. You know, you can use hosted versions of all of these systems, so you don't have to run them yourself. Cool. Okay, so optional microservices. So there's 2 ways you can run Loki, basically. You can run it in the easy way, which is where it's just a binary. It's horizontally scalable, so you can run as many of them as you like. You know, and then you run a Promtail on each host, and you just have it pushed to a random one, and it will do routing amongst itself, and it's scraping your applications. Or, if you're a masochist like I am, you can run it with a different flag that breaks it down into a whole bunch of different microservices. So you can run the distributor, which distributes data to ingesters, which build chunks, which flush them, a separate query pipeline. Well, this is actually the architecture diagram from Cortex, and for those who have dug into the code base of Loki, they'll notice that Loki is just Cortex for logs. Like we've just like said and replaced every occurrence of time series with log stream, and it kind of just works. So you can run it in this nice deaggregated mode. And one of the nice things about this disaggregated microservice architecture is you can like independently tweak the size of the jobs. So if you've got a particularly like query heavy workload, you scale up the query side, you scale up the query caching and all of that side. If you've got a particularly write-heavy workload, and actually, let's face it, logs is particularly write-heavy, you scale up this write path, the red bit, way more than you scale up this. And you can also use it to kind of isolate failures. So one of the things we do quite a lot is we iterate on the querier a lot quicker than we iterate on the ingester and the write path. Because the write path is stateful. You kind of have to be careful. You know, a bug there could lose data. Whereas on the query path, it's all stateless. Like, just do what you like. If it breaks, we'll just roll it back. And so you get these 2 modes. And this, I guess, like when we launched the Cortex project, this was what was missing. We did Cortex in this microservice-oriented architecture. You know, it's super fantastically complicated. Cutting edge and everywhere. It's gRPC streaming, you name it, it's all there. And for the newcomers, it's just impenetrable. It's really hard to get started with. And so with Loki, we put a lot of effort into making it really easy to get started with. So we put a lot of effort into this mode, making it all run in a single binary, making it all run on your laptop, making it all run without dependencies. So, do you want to see a demo? Okay, I'm going to have to put down there. The only reason it was a question is because it didn't work last time I tried. So bear with me on this. It might be a bit flaky. I've been doing a lot of work on it recently. Obviously, our hosted version is super stable. So let's just stop it. Oh, my mouse doesn't work. So, can everyone see my screen? So I'm going to just build it from source. This is just a Git repo. This is running master, I believe. Yeah, good. So first you want to run Loki. So this is just going to build it. It's going to delete the temporary files that I've got. For some reason my mouse won't scroll further to the right. And it's going to run it with a special config file that's set up for local running. So let's go. Just takes a minute. Go build used to be so much quicker. Does anyone know why my mouse is doing this? It's really strange. So how do I change tabs if I can't click on it with my mouse? Anyone? I'll tell you what, I'll just move it over. There we go. So next we're going to run Prometheus, which is the agent. Well, an often question I get before anyone asks, and why we had to build our own agent and why we didn't use Fluentd, is because of that whole service discovery piece. We needed those labels to be the same. And Fluentd obviously doesn't integrate with Prometheus or anything like that. This is going to run the agent. Now, I don't actually have a Prometheus running here, so the agent's just going to scrape whatever's in var log. The only labels I'm going to have are file name. And then the final piece, this is just running Grafana. All of these instructions are in the README, or something like that. I'm going to just unplug this and plug it back in, so I can get my mouse back. So, localhost. Everyone's familiar with Grafana, everyone knows the password. No, I don't need to change it. Then we're going to add a data source. And it's a Loki data source. Nope. This is where I have to guess. So the Grafana's running in Docker inside a VM on the Mac, and the Loki's running on the Mac itself, so you have to use some strange URL, which I have highlighted here. host.docker.internal. And then we go to test, and it worked. And this is the new explore mode. So normally, if you're using Prometheus, you can put Prometheus queries in here, and it's got tab completion. This will all be released in Grafana 6.0, which is coming out, is it still January? Last January, so it's coming out like the end of February. It's coming out next month, but tomorrow, very soon. I think Beta 1 actually came out today. Anyway, so, and the same tab completion and the same query language effectively that Prometheus uses works for Loki. I mean, it's literally just the same code. So we can say, what file would you like to do the logs of? And that's it. Now, there's a lot more stuff to show you if you have Prometheus integration, all the labels there. Plus, David, the chap who writes the front end for this, has done some really cool stuff with understanding like different log formats, but I'm just looking at the Mac logs and it's really dull. But that's basically the log aggregation UI for Loki. So, just to wrap up, what is Loki? What do we try to do with Loki? We tried to make it simple and cost effective. You can all read. We've tried to integrate it with existing observability tools and get this kind of this workflow of automatically switching between these different aspects. And you can kind of obviously see what we're going to do with tracing as well. My project for kind of the second half of this year. And we've tried to architect it in a real cloud native way. Okay, that's it. Thank you very much. Does anyone have any questions? We'll start back. Blue shirt.
Maybe start by like numbers because
sorry. What's next? Pitch. Hello.
Hello. So if it's if the log data is not that labeled, it's not searchable then?
Yeah.
So you cannot search by the actual log?
Not the stuff inside the logs.
Only the labels.
If you use the labels to narrow down the set of streams, you can, just brute force it with a regular expression, which will get distributed out to all of the nodes running Loki, so it's kind of parallelized.
Okay.
But no, like the whole point is that we've not indexed the logs. And generally, the whole idea with Loki is that you use it in conjunction with Prometheus, and use Prometheus to kind of narrow down the time range and the job and the labels that you're looking for.
Okay.
But no, that's the trade-off. So we'll go with this chap in the middle, and we'll come to you. Thank you.
Thank you. I got two questions. First one is, do you have any, did you test the performance regarding FluentD, which is in Ruby and pretty CPU intensive?
I've not done much testing of anything.
Okay.
But I've used FluentD extensively, and I'm familiar with its resource consumptions. Which is why one of the other reasons why I really wanted to build Prometheus.
Okay.
Like I really wanted something that was written in Go, that I could, that was a bit more focused and a bit quicker, let's face it.
And my second question is regarding multi-line logs. When you have one, yeah, I know. That's why I'm asking it.
Yeah.
Fast.
Yeah. So no. Don't have a good answer to that. Like everyone else, don't have a good answer to that.
So no Java stack for us.
Exactly, yeah. So what actually, as a complete cheat, what we do is we intercept the stack trace, with a signal handler in our Go function, in our Go applications, and we just then take the stack trace, encode it as a string with /ns and /quotes, and then print it out on one line.
Correlated, users said that the message was bytes, so it's basically how do you manage the encoding of a message?
Yeah, so it's bytes in, bytes out.
Okay.
Which kind of mean, we don't take an opinion on that.
Okay, so you see, if you have garbage in, you have garbage out.
Exactly, and that's kind of UI's problem. David, the chap who writes the front end, he's got a whole bunch of different parsers in the UI for interpreting what's inside the strings, and we want to build a lot of the cleverness into that. We really want to kind of avoid these hand-rolled FluentD configs that treat every log specially.
Yeah, because I want a lot of my FluentD configs like something like remapping UTF-8 to something else to avoiding minus in the stream.
Yeah, that's front-end problems.
Okay.
For Loki on the back end, we just treat everything as bytes.
Okay, I'm just going to interrupt you one more. Do you have any ingress for I don't know syslog traffic, something like that?
So no, Loki's really early, right? I mean, I've no reason why we couldn't have this.
Yeah.
We've been working on journald, because journald has just enough metadata as well to kind of make it useful. So there's a PR open to do journald integration in Prometheus. The other thing we've done is we've actually, for everything I've said about FluentD, we've written a FluentD plugin. And FluentD has everything, right? So everything can be done through FluentD if you want, but you kind of have to do it yourself. And that has, syslog ng and all this kind of stuff. And we're really open to these kind of integrations. So we've recently added, because I'm a bit of a cloud native person, everything's in proto buffers, everything's with Snappy, everything's gRPC, which makes it really hard to push data to the system. So we've added a JSON HTTP interface to make it easier for these, which the FluentD interface uses. So we want to make it easy to integrate with things. Is that iPhone filming me? Oh, I didn't think I was being filmed. Okay, there's one more question down here.
One question regarding the Kubernetes integration. Currently, Kubernetes logs almost all events, not all of them. Do you plan to extend the Loki to, index events?
Yeah, I mean, that would be really cool, because I know, at least we run on GKE, and GKE throws away our events very quickly, and we don't like that. I haven't thought about it. You're the first person to ask that question. I think that would be awesome. I see no reason why we shouldn't do it. Our integrations with Kubernetes are generally at the service discovery level. And, we're currently exploring, what's the new framework for container drivers? I forget what it's called. But there's a new, you don't have to use Docker anymore. You can use containers.
Oh, CRI?
Yeah, CRI. So we're currently starting to talk about, integrating with that to get our logs. Because currently the way we scrape our logs is a bit Docker specific. you know, Docker writes out its logs as a single line JSON with a timestamp, blah, blah, blah. So, you know, we're just opening that kind of Pandora's box at the moment.
Thank you.
Thank you. Any more? Awesome. Thank you very much.